You ever gazed up at a massive airplane soaring overhead and wondered how something so heavy can float through the sky? It's a question that fascinates both kids and adults alike. Airplanes, even when fully loaded, can weigh hundreds of tons, yet they glide smoothly above us. The answer isn't magic, it's science. In this video, we'll unravel the secrets behind flight and discover how airplanes manage to stay up. We'll explore the invisible forces at work and see how pilots and engineers use them to keep planes flying safely. Let's begin our journey into the science of flight. Every airplane in the sky is controlled by four main forces. These forces are constantly at play, working together to keep the plane airborne. First, there's lift, which pushes the airplane upward. Then there's weight, which pulls it downward due to gravity. Thrust is the force that moves the airplane forward, generated by its engines. Finally, drag is the air resistance that slows the plane down. When these four forces are balanced just right, the airplane can fly smoothly and safely. Understanding these forces is the key to understanding flight itself. Lift is the upward force that allows airplanes to rise off the ground and stay in the sky. It's created mainly by the wings. When an airplane moves forward, air flows over and under the wings. The shape of the wing causes the air above to move faster, creating lower pressure on top and higher pressure below. This difference in pressure pushes the wing and the airplane upward. Without lift, flight would be impossible. It's the most important force for keeping airplanes aloft. Wings of an airplane are specially designed to create lift. If you look closely, you'll notice the top of the wing is curved while the bottom is flatter. As the airplane speeds forward, air travels faster over the curved top and slower underneath. This creates lower pressure above and higher pressure below the wing. The result, the airplane is pushed upward. This clever design is what allows even the heaviest planes to rise into the sky. The science behind wing shape is called aerodynamics, and it's crucial for flight. Airplanes need more than just lift, they also need to move forward. That's where thrust comes in. Jet engines or propellers generate thrust by pushing air backward, which moves the airplane forward. In jet engines, air is sucked in, compressed, mixed with fuel, and ignited. The hot gases blast out the back at high speed, propelling the airplane ahead. The faster the airplane goes, the more lift its wings can create. Thrust and lift work together to keep the plane flying. Let's take a closer look at how jet engines work. First, they suck in air at the front. This air is compressed and mixed with fuel. When the mixture is ignited, it creates a powerful explosion. The hot gases rush out the back of the engine, pushing the airplane forward. This forward movement is called thrust. Without engines, airplanes wouldn't be able to move fast enough to generate lift and take off. As airplanes move through the air, they face resistance called drag. Drag is caused by air molecules pushing against the airplane as it flies. It acts in the opposite direction of thrust, trying to slow the plane down. Engineers work hard to design airplanes that are sleek and smooth, reducing drag as much as possible. Less drag means the airplane can fly faster and use less fuel. For an airplane to fly safely, all four forces lift, weight, thrust, and drag must be balanced. If lift is greater than weight, the airplane climbs. If weight is greater than lift, it descends. If thrust is greater than drag, the airplane speeds up. If drag is greater than thrust, it slows down. Pilots and computers constantly adjust the airplane's speed and angle to keep everything in balance. Gravity is always working to pull the airplane back down to Earth. This force is what gives the airplane its weight. To stay in the air, the airplane's lift must be strong enough to overcome gravity. Pilots monitor the plane's speed and angle to make sure lift stays ahead of weight. If lift drops too low, the airplane will start to descend. Pilots have several ways to control lift and weight during flight. By changing the airplane's speed or adjusting the angle of the wings, they can increase or decrease lift. If the airplane needs to climb, the pilot increases speed or raises the nose. To descend, the pilot reduces speed or lowers the nose. This careful control keeps the airplane flying smoothly and safely. Takeoff is one of the most exciting moments in flight. The airplane speeds down the runway, engines roaring. As the speed increases, the wings generate more and more lift. When the lift is strong enough to overcome the airplane's weight, the plane leaves the ground and soars into the sky. Pilots carefully control the speed and angle to ensure a smooth takeoff. During takeoff and landing, pilots use special parts of the wing called flaps. Flaps can be extended to change the shape of the wing, increasing lift at lower speeds. This helps the airplane take off and land safely, even when it's moving slower than usual. Flaps are a key tool for pilots during these critical moments. Landing is the final stage of flight. As the airplane approaches the runway, pilots reduce speed and lower the flaps. This increases lift and allows the airplane to fly slowly and steadily. The wheels touch down gently and the airplane rolls to a stop. Careful control of speed, lift, and flaps ensures a safe landing every time. Airplanes are designed with smooth, streamlined shapes to help them move easily through the air. The rounded nose, sleek body, and tapered wings all help reduce drag. Engineers use wind tunnels and computer models to test and improve airplane designs, making them more efficient and safer. Aerodynamics is the science of how air moves around objects. For airplanes, good aerodynamics means less drag and more lift. Engineers study airflow over wings and bodies to make sure airplanes fly smoothly. Every curve and angle is carefully planned to help the airplane cut through the air with ease. Pilots are trained to manage all aspects of flight. They monitor the airplane's instruments, adjust speed and altitude, and respond to changing weather or air traffic. Pilots use their knowledge of the four forces to keep the airplane balanced and safe throughout the journey. Weather can have a big impact on how airplanes fly. Strong winds, rain, or turbulence can change the balance of forces. Pilots and air traffic controllers work together to keep flights safe, adjusting routes and altitudes as needed. Modern airplanes are built to handle a wide range of weather conditions. Runways are specially built surfaces where airplanes take off and land. They are long, flat, and strong enough to support the weight of even the largest planes. Pilots use runways to gain the speed needed for takeoff and to slow down safely after landing. Air traffic controllers guide airplanes safely through the sky and on the ground. They use radar and radios to track each plane's position and give instructions to pilots. This helps prevent collisions and keeps air travel safe and organized. Airplanes need fuel to power their engines and create thrust. Jet fuel is stored in the wings and tanks of the airplane. Efficient engines and lightweight designs help airplanes use less fuel, making flights more economical and environmentally friendly. At high altitudes, the air is thin and hard to breathe. Airplanes have pressurized cabins to keep passengers comfortable and safe. Special systems pump air into the cabin, maintaining a steady pressure and temperature throughout the flight. Airplane wings do more than create lift, they also help keep the airplane stable. The shape and position of the wings help balance the airplane in the air, preventing it from tipping or rolling. Tail fins and rudders also play a role in stability and control. The tail of an airplane includes the horizontal stabilizer and the vertical fin. These parts help keep the airplane flying straight and level. The tail prevents unwanted pitching or yawing, making the flight smoother for everyone on board. To turn in the sky, airplanes use movable parts called ailerons and rudders. Ailerons on the wings tilt the plane left or right, while the rudder on the tail helps steer. Pilots use these controls to make smooth, safe turns during flight. When an airplane needs to slow down, pilots can use air brakes or spoilers. These are panels that pop up on the wings, increasing drag and reducing speed. Air brakes help the airplane descend and land safely. Landing gear is the set of wheels and struts that support the airplane on the ground. During flight, the landing gear is retracted to reduce drag. When it's time to land, the gear is lowered again for a safe touchdown. Modern airplanes use advanced computers to help pilots fly safely. These systems monitor the airplane's position, speed, and altitude, and can even make small adjustments automatically. Computers help make flying safer and more efficient. Pilots stay in constant contact with air traffic controllers and other airplanes using radios. Clear communication is essential for safe flights, especially in busy airspace. Radios and other technology help everyone stay informed and coordinated. Most airplanes fly at high altitudes, often above 30,000 feet. Up there, the air is thinner, which means less drag and smoother flights. Flying high also helps airplanes avoid bad weather and turbulence closer to the ground. Speed is crucial for flight. The faster an airplane moves, the more lift its wings generate. Pilots must keep the airplane above a certain speed to stay in the air. If the speed drops too low, the airplane can stall and lose lift. A stall happens when the airplane's wings can't generate enough lift, usually because the speed is too low or the angle is too steep. When a stall occurs, the airplane starts to descend. Pilots are trained to recognize and recover from stalls quickly and safely. Pilots use their training and instruments to avoid stalls. They watch the airplane's speed and angle, making adjustments as needed. If a stall starts, pilots lower the nose and increase speed to restore lift and return to safe flight. Flaps are especially important during landing. By extending the flaps, pilots increase the wing's surface area and lift, allowing the airplane to fly slowly and land gently. Flaps also increase drag, helping the airplane slow down as it approaches the runway. Modern airplanes are some of the safest ways to travel. They are built with strong materials, advanced technology, and multiple backup systems. Pilots and crews are highly trained, and every flight follows strict safety rules. All of this helps keep passengers safe in the sky. Flight is a perfect example of science in action. Physics, engineering, and technology all come together to make airplanes fly. By understanding the four forces and how they interact, we can appreciate the amazing achievement of human flight. Airplanes have revolutionized the way we travel. They connect people and places around the world, making it possible to visit distant countries in just hours. Air travel has made our world smaller and more connected than ever before. The future of flight is full of exciting possibilities. Engineers are working on new airplane designs that are faster, quieter, and more environmentally friendly. Electric and hybrid planes, as well as new materials, will make flying even safer and more efficient in the years to come. Did you know the largest passenger airplane, the Airbus A380, can carry over 800 people, or that some airplanes can fly faster than the speed of sound? Airplanes come in all shapes and sizes, each designed for a special purpose. Pilots go through years of training before they can fly commercial airplanes. They learn about aerodynamics, weather, navigation, and emergency procedures. Flight simulators and real-world practice help them prepare for any situation in the sky. Engineers design and build airplanes, making sure every part is safe and efficient. They use advanced tools and technology to test new ideas and solve problems. Without engineers, modern flight would not be possible. Airplanes are carefully inspected and maintained before every flight. Mechanics check engines, wings, and all systems to make sure everything works perfectly. Regular maintenance keeps airplanes safe and reliable. Passenger safety is the top priority for airlines. Safety briefings, seat belts, and emergency equipment are all part of keeping everyone secure. Flight attendants are trained to handle emergencies and help passengers stay calm. Flying is an incredible experience. Watching the world from above, traveling to new places, and feeling the power of flight is something special. Thanks to science and technology, millions of people can enjoy the magic of flight every day. Let's recap what we've learned. Airplanes stay in the sky because of four main forces: lift, weight, thrust, and drag. Wings create lift, engines provide thrust, and pilots balance all the forces for safe flight. It's a perfect blend of science, engineering, and skill. Next time you see an airplane soaring overhead, you'll know the secrets behind its flight. From the shape of the wings to the power of the engines, every detail is carefully designed to keep it in the sky. Airplanes are a true marvel of human achievement, blending science, technology, and imagination to make the impossible possible.